The resistance of the four arms P, Q, R and S in a Wheatstone bridge are 10 ohm, 30 ohm and 90 ohm respectively. The EMF and internal resistance of the cell are 7 volt and 5 ohm respectively. If the galvanometer resistance is 50 ohm, what will be the current drawn from the cell? This question involves the Wheatstone bridge circuit and the calculation of the total current drawn from the cell. Let us analyze it step by step. The Wheatstone bridge is balanced if P by Q is equal to R by S. Here P is 10 ohm, Q is 30 ohm, R is 30 ohm and S is 90 ohm. And P by Q is equal to 10 by 3 which is 1 by 3. And on right hand side R by S is equal to 30 by 90 is equal to 1 by 3. Since P by Q is equal to R by S, the Wheatstone bridge is balanced, meaning no current flows through the galvanometer. When the bridge is balanced, the two branches P, Q and R and S can be considered as two parallel resistors. Their equivalent resistance can be calculated as R left is equal to P plus Q is equal to 10 plus 30 is equal to 40 ohm and equivalent resistance in the right branch is R plus S is equal to 30 plus 90 which is 120 ohms. Finding effective resistance of the two branches in parallel, we get R effective is equal to R left into R right divided by resistance in the left plus resistance in the right. Substituting the values of resistance in left and right, we get R effective is equal to 40 into 120 divided by 40 plus 120, which is equal to 4800 by 160, which is nothing but 30 ohm. The total resistance in the circuit is the sum of effective resistance and the internal resistance of the cell, which is small r. Therefore, R total is R effective plus R, which is 30 plus 5, which is equal to 35 ohm. Now let us calculate the current drawn from the cell. Using Ohm's law, we have I is equal to V by R total. Substituting the values of V and R total, we get current I is equal to 7 by 35, which is nothing but 0.2 amps. Therefore, the correct answer is option A, 0.2 amperes.